Welcome to part 2 of the Algebra 2 mini crash course. Part 2 of 4 is going to be on radicals and little quadratics, solving quadratics with radicals. Once again, we're in part 2, so here's the entire crash course overview. We should have done part 1 already, and part 3 and 4 is factoring continued afterwards. Links are in the description for Get Ready for Algebra 2 and Algebra 2 for Khan Academy. Check those out when you got time. All right, going to head right into more of a discussion and introduction to radicals in general. Radicals, right, are essentially what you would be familiar or actually call, right, aka square roots, is what you're probably most familiar with. And they look like this, right? This little sign, square roots, and generally when you have square roots, right, it's something multiplied by something. You could do by like a factor of 2 or 3 or 4, right? You could do other things, but generally, right, it's square roots by a factor of 2, and here's what they look like, right? So conceptually speaking, right, we do understand that something like 3 squared, right, equals 9, right? Because 3 squared is 3 times 3, and that equals 9. But what if we were to think about 9 and like take that and be like, hey, with this number 9, right, what times what would equal 9, right? And this is essentially what the radical is for, and square root, right? So we would have 9 here, and then we put our radical, and the answer we would get would turn out to be 3, right? Because we know 3 times 3 is 9, and the radical basically shows the inverse of that. So essentially, right, this relationship, this back and forth relationship that we can paint is radicals in a nutshell for square roots, right? We can do the same thing, right, with, we can apply to 4, right? 4 squared. 4 times 4, right, is 16. And then we can take a radical, right? We can go the opposite direction again. Square root of 16 is 4. And then in this case, let's start with the radical, right? We have 25. Square root of 25. Can figure out it's 5. And this checks out, right? Because we have 5 squared, which is 5 times 5 equals 25, right? So it's interchangeable, and we can do that. So then what we also have, what can also multiply by each other and kind of equal 9, actually is a -3, right? We can do -3 squared, which is -3 times -3, negatives cancel out, and 3 times 3, and we have 9, right? So -3 also works, right? And we can do with -4, -5, and so on to equal all these square roots. And so that's something to know, that the negative side can also work. So typically, right, depending on what kind of math or who you're talking to, what kind of mathematicians you're talking to, but typically, right, this radical here is called the principal. I think it's principal, square root value, something like that. And essentially, it's agreed upon when you see this radical, right? This number, right? The value is going to be positive, right? So we're essentially, this, we know it's going to be 3, right? And technically speaking, right, it can also be -3, but it's understood that when you see this radical, it's just they're asking for the principal value, which is going to be positive. What you can actually do though, right, is you have -3 squared, right, which equals 9, but you can, right, you can take the square root of, you can actually take the square root of this value, the square root of that value, and, right, you get rid of the squared here, you get -3. Let me just write it as a single thing, -3, and then this, right, also equals -3. That's where we get that -3 from. So when we have right, this principal square value, essentially they're asking for the positive version, but it gets a bit different, right, when we have x squared equals 9. This is different, right? So why? Because we kind of have these value. We don't have the radical or the principal square root value thing over here to indicate. And how we're going to solve this, right? Typically, right, you then draw in the radical and then draw this over, and then to help you, right, figure out the problem, and you'd be very inclined to call it the root, right? But when you introduce this radical on your own, you can't just say, oh, it's like principal value or whatever. You have to be aware that, right, the square root of 9 here can also equal the negative version. So that's where we get, it can be plus or it can be minus, right? So x can either equal 3 or x equals -3. And this is signified the plus or minus sign that we can put ahead of this. So quick refresher, right? So if you see like a problem that gives you the square root and it's like the principal square root value, just know that you're going to be asking for a positive version of a positive number plus 4, right? But when you get an equation kind of like here, let's ignore the square root, where it starts off with just x squared equals 9, and then we ourselves are introducing this radical, just understand that it can either equal 3 or -3. So beware, don't forget that plus or minus sign in front. So that's just a quick, brief introduction to radicals. There's a couple questions with a few radicals. I believe it entertains like 12 squared or 13 squared, 14 squared. Just a quick problem set there. And what we can do now is move on to quadratics and work on solving quadratics with radicals, right, and square roots. So in this scenario, right, what we essentially want to do, right, we see something, the way I always like to approach problems is I always see something that so-and-so like makes me uncomfortable and I want to get rid of it and kind of simplify it to make my life easier when solving. And in this case, right, whether it be like parentheses or fractions or whatnot, or different variables and stuff like that. But in this case, right, it's this right here, where we have an exponent x squared, and I want to look to get rid of that. And we can do that using a radical. First things first, right, we want to isolate the variable. And we can do this, right? We can -6 on this left side to get rid of the 6. And what we do to one side must be done to the other. And then essentially what can be done is 5x squared is put down here, right? These 6's cancel out. And then 75 minus 6 is going to be 69, right? So after that, what can be done essentially, right, is we want to isolate this x squared, so we can bring 5 over, right? We can divide by 5 from both sides, and then these 5 cancel out. We'll be left with x squared, and we're essentially going to get this fraction. I can convert it to decimal form really quick, and we're going to get to like 1, 3, let me just do it really quick over here, right? 1, 5, 9, 3, 15, 4, 0, so 0.8. So we're going to get a 13.8. So we're left with this, right? And then what we want to do is we want to isolate, right? The square, we want to get rid of it. So we can do a radical here. And what we can do, right, is introduce it on the other side as well. What we do on one side must be done to the other. And we're going to get, right, what we're going to get essentially is radical here, 13.8. Then we can also do a plus minus to show that we know it's going to be, it can be a plus or minus because we introduced this radical in and of itself. This problem is a bit different. I just mixed up the numbers, so it doesn't turn out to be the perfect number that we can actually like do a square root off the top of our head. I believe if we do the calculator really quick, it's going to turn out between like the numbers 3 and 4. So it's going to like be a 3 point something decimal, right? How I know this, how I do this approximation, right? I do understand that 3 times 3 is 9, and then 4 times 4 is 16, and this 13.8 is between 9 and 16, so that can give me a general ballpark. This is helpful when you get like multiple choice test questions, and they don't necessarily expect you, to memorize the square root of 13.8 right off the top of your head. You can just use this general approximation, right? Typically, you get choice A, B, C, and D, right? And the answer choice is going to be like 2.4, 18.5, 3.4-ish, right? And then we have like 16.2. And then with this, right, you can guess, oh, 3.4, C is your option, and that's the general gist. All right, so moving on, we're going to have a slight variation of how to solve quadratics using radicals. And essentially in this, right, what's the one thing that's making me uncomfy, right, are these parentheses coupled with this exponent. So what we can do is, first things first, we can get rid of this exponent through radicals, but before we can get to that, we want to isolate it, and to do that, we can do what we're used to doing with linear equations, and what is done to one side must be done to the other. So we can divide this left side by 3 to get rid of this 3 on the left side, and then we do it to one side, do it to the other side, right? And then we go for it. So basically these 3's cross out, we're left with x minus 5 squared, and then 48 divided by 3 is 16. And then this number is going to line up really nicely with our radical. What we can do, right, to get rid of this exponent, we can do a radical, right, and do this. Keep in mind, right, we are introducing this radical now. It's not a principal square root value. And what we're going to have to do, right, is be aware of that, right? This radical can get rid of the squared, and we have a square root 16 over here left over. You know, I personally recommend this just to keep this in track, like, right? I would honestly put it like as early as up here, this plus or minus, to remind you, right? You can get this plus or minus value. And this is important as we're going to get differing x values for our final answer. So we can do an x minus 5. Let's simplify this radical because it's possible here with our mental math, is plus or minus 4. We still haven't isolated x all the way completely, so how we can do that, right? We can add 5 to the left side to get rid of this negative 5, and then what we do to one side must be done to the other, so we add 5 to the other side. The 5's cancel each other out, we're left with the x, and then what we have here, right, is we're adding 5, right, so it's positive 5, and then we have our plus or minus 4 introduced by a radical that we put on top of 16. So how does this play out? Well, we have two versions of x, two possible answers for x, right? We have x1 equals, and let's do the first method. Let's do, so we can choose between positive or negative. I'm going to just choose positive. So 5 plus 4 is 9. And then the second version of x subscript 2, we can do 5 minus 4 this time, and we're going to get 1. And essentially, we're going to get x1 equals 9 and x2 equals 1. How we can do this, like say we want to double check and make sure, we can directly, right, plug in these values one at a time into our original equation to see if, right, this equality, this equal sign, right, actually holds true. So let's take this problem, let's copy it over, back down, keeping in mind, right, we essentially want to test our x1 and x2 values. And how we're going to do that really quick is just kind of quick substitution, right? Let's say for x1, we have 3, then replacing this x with a 9, 5 squared equals 48. So, right, 9 minus 5 is 4, 3 times 4 squared equals 48, and then 3 times 16 equals 48. 3 times 16 is 48. 48 equals 48. That checks out. I really, now I truly believe, right? I really understand that x1 truly does equal 9 here. Let's see if x2 works. So we can do the same thing, 3, and then replacing x instead of this time, instead of 9, we're doing 1 minus 5 squared equals 48. And then what we're going to get is 3 times negative 4 squared equals 48. Now you look over to the left, you see this, it's almost identical, except of positive 4, so negative 4. But this makes sense, right? Because we know negative 4 times negative 4 squared is the same, right? It's going to resound the same as 4 squared, right? And this checks out, so we continue down the line. 3 times 16 now, 48, and we get a 48 equals a 48. This checks out. X1 is 9, X2 is 1, or you can write, x equals 9 or 1, whichever way you like. And that is radicals in a nutshell. And that is solving quadratic equations in a nutshell. Essentially, quadratic equations, right, are whenever you have, some equation like this, and we have a variable up to x power of 2, right? As we go into the future, where we get like x power cubed, this is like a cubic function, whereas this is quadratic, and then we can get like crazy. We definitely won't be touching into this, but x to the power 4, x to the power 5. I don't even know what those are called, but quadratic equations essentially, right? We get something to the power of 2. But yeah, so in the future, right, when you go into Algebra 2 class, you'll probably run into problems that have like plus 5x and then plus 14, right? So we have x squared and x and plus 14 equals some arbitrary number like 0, for example. That would be 9, so 5, right? But when we have a problem where it's just x squared, we don't have an x to the power of 1, right? We just have a couple numbers, 6 and 75, right? We can look towards radicals to solve these kind of problems for us. So essentially, whenever I see problems with only an x squared, no singular x, and the rest is just constants, I'm looking to radicals to help me solve this problem. Hopefully that helped. And yeah, have a good one.